Welcome back. In this video, we're going to talk about alkyl halides. Alkyl halides are one of the functional groups we're studying in Chemistry 30, along with alcohols, carboxylic acids, and esters. Alkyl halides have a halogen substituted for a hydrogen atom anywhere in the hydrocarbon. So as a reminder, the halogens are fluorine, chlorine, bromine, or iodine. Those are the ones we typically see substituted in for hydrogens in a carbon chain. When studying functional groups, they're often written in terms of some carbon chain represented by a variable R, and then X representing a halogen atom, some halogen atom, X being one of fluorine, chlorine, bromine, or iodine. R is usually just meant to mean any carbon chain of variable length. So the alkyl halides are soluble in water to an extent. The halogen that they have there provides some polarity. Fluorine, if it's in there, would allow the molecule to participate in hydrogen bonding. If it's chlorine, it would at least have some dipole-dipole interactions because fluorine and chlorine are some of the more electronegative atoms. With size, though, increasing size is going to make them less soluble in water. And that's generally a trend. The bigger the molecule is, the less soluble it's going to be in water. Unless it has like lots and lots of polar components to it. So the boiling points tend to be higher than alkanes, but lower than alcohols. They're higher than alkanes of the same carbon chain length, primarily because of those polar interactions. It will at least have some dipole-dipole interactions, which increases the energy requirement to separate the molecules. It's going to be less than alcohols because alcohols will always be able to hydrogen bond because every alcohol is going to have at least an oxygen in there somewhere bonded to carbon and bonded to hydrogen. So that creates the potential for hydrogen bonding, which the alkyl halides, with the exception of ones that contain fluorine, won't be able to have. So boiling points for the alkyl halides are somewhere between alkanes and alcohols of the same carbon chain length. When we name them, the halide functional groups get prefixes based on their name. So F becomes fluoro, chlorine becomes chloro, bromine becomes bromo, and iodine becomes iodo. If we have multiples of them, then they get the prefixes di, tri, and tetra based on whether it's 2, 3, or 4, respectively, of them in the compound. So now we're going to look at a few examples of how to name these. This one here, we've got a 4-carbon chain. Bromine is bonded to the carbon right on the end. And it looks like we've got 1, 2, 3, 4. This is our first carbon right here. So bromine's bonded to it. So that would be 1 bromo. And the parent is a butane molecule. So this would be 1 bromobutane. Here we have a 5-carbon chain, and we have a bromo group bonded to carbon number 2. So the 5-carbon chain gives it the root of pentane, and bromine bonded at carbon 2 gives it the prefix of 2-bromo. So put it all together, this becomes 2-bromopentane. In this example, we've got an aromatic alkyl halide. We've got the benzene ring here, so that means the parent is the benzene molecule, and we just have a chlorine bonded directly to it, so this would be chlorobenzene. We don't need to include a number here because it's assumed that the chlorine is attached to carbon 1. Even if you were to rotate this molecule, it would always be bonded to carbon 1. When we need to start numbering things is when we have other groups attached or another chlorine group attached, and that's when we have to use numbers to show the position of those groups relative to each other on the parent. So this can just be chlorobenzene. All right, and that's our brief introduction to alkyl halides. There's not much there. They're generally used industrially, like they can be very toxic, and um, some of them have done a lot of damage to our atmosphere, particularly the chlorofluorocarbons. Those are hydrocarbons with chlorine and fluorine in them. Um, so yeah, there we go. I think we'll kind of return to these a little bit later on when we start looking at reactions of alkyl halides. See you then.